I just recreated a large part of Notion's UI for my own application called Seneca, and I have a couple of notes that I want to share about what Notion gets right and how it does what it does. So let me start off by telling you what the best things I like about Notion and what I was doing when I wanted to approach solving this problem, right? What Notion gets right is one, it's very customizable, which means almost everything that you like to do, which is databases, tables, graphs, text, whatnot, is at least to some extent customizable by you, which includes colors, fonts, highlights, etc. That's one. Two, everything's really snappy, which means there's syncing that's going on, but also offline, online, everything just happens quickly. And this is particularly true for the application on your device versus compared to the web. But I think the web application itself is very snappy as well. Three is that it makes it very easy for the user to keep coming back to it without having lost any of the data. What I mean by that is your data is synced across several devices at the same time. Even though you might be offline, the background syncing happens in such a way that you don't have to think twice about what's going on. Four, people get to do Notion pages in teams, so that means that the whole company can be leveled on a single platform, and it acts as a communication channel as well on top of a note-taking business channel. And five, I think the last, which is also in my opinion the most underrated part, is that Notion's UI, even though we might not appreciate it, is so minimal yet so powerful that you almost don't have to think about what you're doing. But everything from making tables, adding new rows, using AI, creating new pages is so intuitive that it almost feels like second nature, and that is, I think, a very intentional choice that they went with. Right? So these are the 5 points that I wanted to prioritize when I wanted to implement Notion from scratch. So here's my notes on how to do this. Full disclosure, the GitHub repo for this is open source. So this is a part of the Seneca repository, which itself is open source. So feel free to go to the /web directory in the GitHub, and I'll link that below as well. Two, a large part of that code is written by AI, but the system design was done by me. 90% of that code is written by AI, and I think that should not be a problem considering it's well documented in the docs. Cool. So disclosures out of the way, here's what I learned. One, how does Notion maintain the syncing, all of that, while also maintaining the snappiness? There's 3 things that it does and 3 databases that it uses. One, everything that you do on your device, this is the web as well as the application on your Mac or on your iPhone or whatever phone you're using, is it saves it to memory first. So the first step towards saving something is the local memory. Let's call that the cache for now, right? So everything is cached as soon as you start writing it. Let's say I wrote text 1, it's cached onto the local memory. 2, as soon as something is cached onto the local memory, if you're using the browser, it is automatically saved to the browser storage, right? So this cache is level 1. Browser storage IndexedDB is level 2, which persists this data so that the cache itself is not interrupted when it wants to sync. It is the IndexedDB, the browser storage, that is saving all of that data later on. Now 3, and the final part, is persistence. So how do you persist data like this? I personally opted for Postgres's JSONB utilization. You can also go for MongoDB. I'm not completely sure as to what Notion itself uses as a database choice, but I think JSONB and normal JSON storage through Mongo or Mongoose, I think, should also work well. But what I did was, at every debounced save, so let's say I just wrote out 5 seconds worth of content, and I just took a pause. Let's say I went for a walk. The IndexedDB realizes that there's no more updates coming in through the cache. The IndexedDB then sends a pull request to the backend, which is where the Postgres is running, and says, "Hi, I want to persist this data in memory. Do you have something that you want to save?" And so there's a syncing mechanism that happens, which checks whether the IndexedDB storage, the data it's coming in, is same or a subset of what was already persisted. If not, it gets added onto or deleted from the content. If it is already saved, let's say, then the request fails and you continue working on it as you do, right? So this is the three tripartite storage service that would ensure that at all times your data is being persisted. Now, what's the benefit of this? The benefit is the local storage itself is on your device, which means that if you're online and if you're not using AI, for example, which uses the internet as a service, if you're offline and if your internet is not working, everything is persisted onto the local storage by default, right? So if your phone is working, everything is persisted. The IndexedDB itself is also persisting on beneath the cache layer, which means that local storage is working by itself so that your speed is not limited, and the IndexedDB is working beneath the cache layer, which means the persistence is not lost. As soon as you come back online, the persistence then sends back a bulk request. The IndexedDB sends back a bulk request which says, hi, you're offline for like 30 seconds. Here's all of the changes that happen during that interval. Do you want to pull this? Again, the syncing mechanism checks if this new data is a subset of what was already saved. If it is, it ignores that request. If it's not, if it's a new or there's some deletions, there's some additions, then that is saved. So that is how the storage mechanism works, using three mechanisms. Now, what is being stored, right? So if you've used Notion, you know that it is not text itself that is being persisted in the way, let's say, Google Docs or Words or Microsoft Word does. I'm not sure about how these two applications choose to do their persistence, but it's drastically different from how Notion does it. So the beauty of Notion is it does not persist text by page, right? It persists references to text. So there's three tables is how I approached it when I was making my application. So the top level storage, which is the workspace basically, is a storage reference that all it contains is the pages and the user ID. So I signed in using SSO. I created my own workspace, let's say workspace 1. Workspace 1 now has 3 pages, let's say page 1, page 2, page 3, with the reference to Hardik user ID //, right? So the workspace table itself, all it's persisting is the pages and the user and the reference to the page and the user. Cool. Next level to that is the page itself. So what does the page store? The page also does not store any text whatsoever. The page is a set of references to blocks. Blocks are where the text is stored. What does the page store? Page is, so the page table would look something like this. So the block ID, the reference to the above block and the block below. So a positional reference, which is to say, is this on position 1 on the page? Is this on position 2 on the page? And so you'll have to ensure that this index is maintained of all the pages being in order. And so this reference is maintained, and then of course you have the workspace ID, which is a reference to the workspace table, so that everything is working smoothly. Cool. So the page table itself. Now realize here that these two tables, they're so efficient at storage that you can create n number of workspaces, n number of pages and n number of workspaces without having to constantly update your JSONB in two positions, which is the workspace and the page table. Instead, you only store your JSONB, which is the text, in one position, which is the block table. So what does the block table look like? The block table looks like a reference to the page, the block ID, which is used to ensure sync between the page table and the block table, and the text. So let's say the text on page 1 says, hi, I'm Hardik. That would be where the text manifests, and the block itself is a block ID, and this is. As soon as I let's say, hi, I'm Hardik, and I click enter, a new block is created, this block is persisted. So what happens here is that instead of each block being a huge store of data, where let's say 3, 4, 5 paragraphs are being stored and it's inefficient, you get a set of blocks which each store different lines. So instead of having a lesser number of rows with a more dense row, you get a higher number of rows with a a less dense row, which is not a problem, since you're actually only storing the text itself, and the references to other blocks is not stored, nor is the reference to nor is the reference to the workspace of the page, which is being stored in the workspace and the page table itself. Cool. I hope that makes sense. So just to recapitulate what's happening, there's a workspace table which is storing the pages and their positional reference. There's a page table which is storing the block and their positional reference, and there's the block table itself, which is the lowest unit of denomination here, which is storing the block ID and the reference to the block and the text to the block. Right. So this is how the storage mechanism happens.